Okay, after we looked at fractions just a moment ago, I realized I was going to run short on time, so I wanted to get to adding mixed numbers and subtracting mixed numbers as they sit in mixed numbers. Yes, you can always put them back into improper fraction form, but let's look at a couple, just an example or so of adding mixed numbers and subtracting mixed numbers, so you understand the carrying and the borrowing that's required. So let's go ahead. Let's take a mixed number. Let's go. I thought I had blue. Okay, I still want blue. So let's go 12 and 1/4, and let's add. Uh, let's let's try this again. Okay, that way I make sure I get the color that I want here. Still, hopefully I put on there 12 and 1/4. Let's add 5 and 2/3. All right, so really all our adding fractions requires is a common denominator. Well, I've made one kind of simple here. 4 and 3, common denominator is actually 12, right? So I've got 12 for a common denominator. Once I've got that common denominator, I can simply apply it. All right, so we come back up here. What did I have to take times 4 to get 12? Because that thing, I have to take also to the top, which gets me 3. Oops, I didn't hit it. There we go. I'm a blue. There we go. I have 3/12, which is common, the same number as 1/4. All right, so let's come over to here, and I had to take this guy times 4 and times 4, which now makes this guy 8. Now I can go ahead and I can say, oh, I've got 11/12. Now, since this number is a proper fraction, there's no carrying to be done. All right, and I'll do another one because I mentioned that just now. Okay, because if this number were bigger than, it was 12/12 or bigger, you would have to carry to get to that whole number. We don't on this case, so that would just be 17, 12 plus 5. All right, so let's do this again. Let's go 2 and 2/3. Let's add it to 4 and, I don't know, 7/8, right? Common denominator here is going to be 24. I'm kind of hurrying through this just a little bit, right? Because I know 8 times 3 is 24, 3 times 8 is 24, common denominator 24. When I take this 3 times 8, I have to take the 8 times 2 and get 16. I take the 8 times, give me just a second here, I've got a mute thing. Anyway, I get 21. And what I'm going to do now is I'm going to add and get 37. And you notice I've got a mixed number sitting up there. So 2 and 4 is 6. I can't leave this number like that. All right. So really, this guy is 24 divided by 37 is 1 with the remainder of 13. Well, I also have this 6 and 1 and, well, 6 and 1 is 7 and 13. 24s. So that would be my answer there. Okay, so I'll give you two different examples, primarily done the same way. Just be careful about that step there. Next, let's go ahead and subtract mixed numbers. And what I'm going to do here is I'm going to give you a nice little number. Let's take 12 and let's subtract 7 and, I don't know, 4/5, right? Now, yeah, you can always have common denominator 5 and go like that. However, subtracting is a little bit weird. All I have to do is have a common denominator. I already know it's 5. The thing about it is, what I'd like to do here is do it all as a mixed number. So I can do that. But I have to borrow from this guy to make this guy. So when I do, just like when I borrow in real numbers, this guy goes down 1. The difference here is when I get to when I go from whole numbers to fractions or decimals, I'm actually pulling parts of numbers. So when I pull parts of numbers, this 1 that comes from here has to have a common denominator. So if you think about it, 11 and 5/5, 5/5 and is 1, add it back to 11, we get that 12. But because this 5 here, I have to have a common denominator, anything divided by itself is 1. So this is 11 and 1, which is 12. And now I've got a common denominator. As long as this guy here is smaller than that guy there, I can go ahead and subtract. So I get 5. 4 from 5 is 1. And 7 from 11 is 4. Okay. If I had a number, let's just make up another number here. Let's go 2 and 1/3. And let's subtract 1 and 3/4, right? Well, I have to have a common denominator. That would be 12. Let's rewrite our fractions as equivalent. So times 4 would be 4. Times 3 would be 9. And now you find out I can't subtract 9/12 from 4/12. I just simply don't have it. So this becomes 1. This other 1 comes way over here and becomes, I'm going to help this out, so I'm going to put it as 12/12. Why 12/12? Because the common denominator is 12. This guy is the 1 that I borrowed from here to make this 1. And 1 is 2, which now makes this guy 16/12. And now it is these numbers that I am looking at to subtract. And now I can subtract 9 from 16. That gets me 7. And this guy, 1 from 1 is 0. So this would be my answer. And if you think about it, right, this is not very far off. This is not a whole digit off. Therefore, I get 7/12. Okay, this number should be between the range of 4 and 5. I get 4. You ought to have some common sense when we go to apply these. Hope this helps.